So just wait for it to record and then I'll start.
This call is now being recorded.
Okay. All right, so there's a couple of things that might come up in geometry that we need to just make sure that we know. First one, okay, so if we're just talking about a point, so these are just reviews. So remember, if you just talk about a point, it could be referring to, a point on the XY axis as something like if you have this point here, it would be around about, if I had the scale in, maybe 3, 1. So that's that point there. So if we're talking about a point at any stage, usually at the start of these geometry, this is called coordinate geometry, where you're given coordinates. For non-coordinate geometry, a point would just be the corner of a shape or where a line would start. So for instance, point A to point B doesn't have a coordinate to it. It's just between A and B here. So that's the difference. This up here is coordinate geometry, which we'll be dealing with later. And this is the kind of geometry, normal geometry, that we're dealing with now. So this is point A and point B. Between them, of course, there is a line. So between 2 points, you can draw a line, which of course we know. We can also draw then a parallel line to that. So, and if we have parallel lines, we symbolize that with these arrows. And those arrows means those 2 lines are parallel to each other. And parallel lines, of course, will continue on forever if they're not stopped at a point like this, and they will never meet no matter how far they go. And back to coordinate geometry, those parallel lines should have the same slope or gradient, which we'll talk about more in coordinate geometry. But for now, these 2 are just never going to meet. We can also then, when 2 lines meet at right angles, so 2 lines meet at right angles, we use the symbol for right angle like so, and these lines are called perpendicular. Okay, so you should remember that, where 2 lines meet at right angles. Sometimes when we're talking in trigonometry, we have a line going at a weird angle like this, and we need to talk about the bearing of that angle, but we'll deal more with that when we get to trigonometry. And if you maybe remember, it's about the angle of true north. So north is just up, so it'll be this angle here that would refer to the bearing. But we'll come back to that when we get to trigonometry. Now, of course, when we start talking about angles, this type of angle is less than 90 degrees. Remember, this is our right angle symbol here. That's 90 degrees. Okay, so if we have an angle less than right angle, we call that an acute angle, which we just saw in our quiz. So that's an acute angle. And of course, 1, so that's from 0, well, we put X in there, up to 90 degrees. No, less than 90 degrees won't be equal to 90 degrees is an acute angle. And then if it's greater than that 90 degrees, and we should know this as well, it is called an obtuse angle. Okay, but obtuse angle is between 90 and 180. 180 then is called, so that's just a straight line. That's a 180 degree angle though, but you can just call it a straight angle or straight line. One that goes beyond that then, so we're keeping getting bigger and bigger. This angle started acute, then it's getting obtuse, then it got straight, and then it's getting even further. So I'm just going to bring it up here. So it's bent even further down. It's more than 180, but not quite 360. So more than 180 is called a reflex angle. And that's between 180 and 360 degrees is a reflex angle. So when it goes beyond that 180. And then, of course, if it's gone so far that it comes back and meets where it started. So it goes all the way around and ends up back here. That full angle is a revolution. There's other names for it, but you can call it revolution. That's 360 degrees exactly. It's a circle pretty much. Okay, so it's 360 degrees in a circle. Okay, so that's our different types of angles: perpendicular, right angle, obtuse, reflex, straight angle. Are all relatively important. Okay. Let's look at our types of triangles. So remember, I'm recording this and I'll put it up later if you didn't quite get all those. So triangles, you just saw. Remember, if we see in a triangle symbols like this, if the sides are marked the same length, then they must be the same sides. So for instance, this one has two angles the same length and two angles the same size and two sides the same length. So that must be an isosceles triangle. At the moment, we don't know what these lengths are or angles are, but we know that they are the same. If all three are marked the same, well, that's an equilateral triangle. So they've constructed a triangle, three lengths the same. So if that's 6, 6, and 6, or 10, 10, and 10, what will the angles be? Well, the angles will always be, because they have to be the same, there's a 180 degrees in a triangle. And if it's divided by 3, because they're all the same, each one of them must be 60 degrees. So in an equilateral triangle, always 60 degrees in the angles. We then, of course, had some other triangle names, one with 3 different sides, so I'm going to mark them differently. One with 1 line, one with 2 lines, one with 3 lines. If there's 3 different sides, 3 different angles then as well. That's called a scalene. 3 different angles, 3 different sides. And then you saw the acute and obtuse angle triangles. Acute angle, all of them are acute. And obtuse triangle only needs one obtuse angle in it. Now what's interesting here is, of course, can we have a triangle with 2 obtuse angles? Well, that'll be quite interesting to draw if we think about it. You remember something we know fundamentally about triangles. 180 degrees is its total. So let's say we've 2 really small obtuse angles. So remember, a obtuse angle is more than 90 degrees. So let's say we have one angle that's 91 degrees and another angle that's 92 degrees. And we need a third angle then to make it a triangle. So let's put it at 1 degree, a tiny angle. Already, because these two are more than 90 and 90, that's 183 before I even add the one that's 184 degrees. So therefore it is not a triangle. You can't draw it. I challenge you to draw a triangle with more than 1 obtuse angle. Just won't work. You can try it here as a sketch. So let's do just 1 obtuse angle. And then where do we put? So either this angle here, so that's an obtuse angle, either this angle here or this angle here has to be an obtuse. We're just going to send it the wrong way. We want it to come back to this point. So if this one's obtuse, it's gone off there. That's already turning into a 4-sided figure. And if this one was obtuse, the same thing. You have to make that more than 90. They won't meet. So you can see it's a mess. That's not going to be a triangle. All right, and then you have your right angle triangle, which I presume you remember just has one right angle for the same reasons. If there was two right angles, just adding them together would be 180 degrees and would never come back to the third point. Okay. That's triangles. Now, of course, triangles isn't the only polygon we will deal with. We'll look at quadrilaterals as well. And actually, we'll look at any polygon we can deal with when we're talking about interior and exterior angles, but we'll come to that another day. We're just going to look at quadrilaterals. Most obvious quadrilateral, four-sided shape, remember. Most obvious quadrilateral is perhaps a rectangle or a badly drawn square. So remember, if you're drawing a square as a quadrilateral, you could mark it like this to say all the ends of the size are the same size. And if you have a rectangle, it might be marked like this. So the longer sides are the same and the shorter sides are the same. So that's a rectangle and a square. You know those, rectangle and a square. They'll have angles of 90 degrees because they're perfect right angle perpendicular angles. All angles 90 degrees, of course. Now, if you push a rectangle out of shape, you'll be ended up with a shape like this. It's kind of pushed out of shape. This length is still the same as this length, and this length is still the same as this length, but we've no longer got 90-degree angles, and of course we know that that is called a parallelogram. You should mark arrows here to say that these two sides are parallel, and then if you want to say that these two sides are parallel, you'll use a double arrow. Okay, because if you use one arrow here, maybe a double arrow here. That might be difficult to see, but hopefully you can. Oh, sorry, Santi, I missed your two questions from earlier. You can ask them now. Focus this. Oh, that was from the quizzes. You can still ask them if I didn't answer them. Okay. Oh, sorry. All right, we'll continue. So a parallelogram is when a rectangle is pushed out of shape. Just trying to get this to focus better. Not sure it's doing that's a little bit better. Okay, I'll try and keep going with this. And then if a square is pushed out of shape, it is called $1 million if you get this right. And you type it in the chat before I write it. Boom. But you spelled it wrong, Jenny, so you don't get $1 million. Sorry. Rhombus. Yes, if you push the square out of shape. Okay? And these angles, if you notice, if you're pushing out of shape, this angle and this angle are going to be the same size. And then this angle and this angle up here are going to be the same size. And the same works for parallelograms. Opposite angles are equal. In a rhombus and a this really isn't focusing. Is it focusing on your page? It's not focusing on my screen. Oh well. Just keep going anyway. Okay, so hopefully you can kind of see better than I can see it. All right. So you can try that. Yeah, it's a bit blurry, I know. I don't know why. Maybe if I just hang up out of this one. Okay, maybe that'll clear it up a little bit. Okay. We will continue anyway. Yeah, so you can test that out if you want. If you get 4 straight edges and you can push them out of shape, and you can always see that those angles, opposite angles, are always going to be the same. When I say opposite angles, diagonally opposite angles will always be the same in parallelograms and rhombus. Okay, there's 2 other ones that are a little bit that are usually asked or can come up. We can have a shape like a diamond or a kite, it's called, if these 2 bottom ones are the same length and the 2 top ones are the same length, like this. That's called a kite. In a kite, only these 2 angles, only the middle 2 are equal. Only the middle 2 are equal. The others, these 2 other ends are not equal because these lengths of sides are smaller here than here, which will affect that. But if they're here, however, a small and a large length meet, and a small and large length meet, so it's a bit like an isosceles triangle in a way. You can see that they would be, if you drew a line through here, they're 2 upside down isosceles triangles, so therefore adding them together on both sides must be equal. But the top angle does not necessarily meet and be the same as that top angle. And then finally we have something like this, which has 2 sides parallel, but the other 2 are definitely not parallel. That's called a trapezoid or a trapezium, either one. These 2 sides are parallel, but doesn't always have to have a right angle. But, all right, so there's a special formula for the area of this. You could always get the area of any quadrilateral by splitting it up into 2 triangles. If you think about it, all of these, so the kite was 2 isosceles triangles. This trapezium, I can split it, if I split it here, that'd be 2 triangles, right angle up here, and just probably a scalene down here. And you can keep doing that with all of them, and they're just 2 triangles. So if they're made up of 2 triangles, all of them, that means the angles must add up to 2 triangles. Must add in all quadrilaterals to 360 degrees, which is because they are 2 triangles. And you can split, you show me a quadrilateral that you can't split into 2 triangles, and I will also give you $1 million. All right. The last thing then we need to look at are when a straight line, 2 straight lines that are parallel have a line going through them diagonally, like so. So this is some angle theory. So it has not a bisector. What's the word again? Can't remember the word. What's it called? Transversal. That's the word. Transversal. Going through it. And before we look at this transversal, we're just going to look at where 2 lines in general meet. So if I have 1 line and it's not parallel to another and just something crosses over, we have some angle theory based upon this. In something like this, you can see that opposite angles are equal. Now I can show you this with 2 pens. That no matter how I move these 2 pens, if we look at these 2 angles here, they will get the same bit smaller or larger no matter how I move them. They're always, as long as I don't shake them like that, they're always equatable. And so are these too. They get equally bigger as one moves and the other moves, until eventually they get so small or so big that they across or on top of each other, and therefore they're two straight lines. And then if you keep going, you can always find that the opposite angles will always be the same length. So opposite angles where two lines meet are always equal. You can always say that. So sometimes they give you an algebra problem based on that. So they can say that this angle is 2x, and this angle then is a very simple example. That's 60 degrees. So what's x? Well, 2x has to equal 60 degrees because they are equal to each other. Dividing by 2 then both sides, x then would equal 30 degrees. Okay, that's not saying that this angle is 30 degrees. It's saying it's twice 30 degrees, which is 60, and then they are the same. So you might get something like that. So that's when two lines cross, which means in this shape that this angle must equal that angle, and so on. All these opposite ones are equal to each other. Now there's some words used for some of the angles in a transversal like this. Some of those words that we're going to come across now are, remember, co-interior, alternate, corresponding, all these things. All right, so we're going to start by looking at some alternate angles. So they're on alternate sides of the transversals. They make a Z shape. So see, they're both under the Z. Now, as if that transversal were to move, those angles would still be equal to each other, because this one's getting smaller, and this one's also getting smaller, and the one on the other side's getting bigger and bigger. So alternate angles make the Z shape. I'm just going to put it over here. Angles, they make a Z, and they're equal. And that's what that diagram shows. Now I'm going to do another diagram for another type. Okay, so I've drawn my two parallel lines. I've drawn a transversal. A bit badly, should probably use a ruler. But if I look at two angles on the inside here on the same side, what did they equal? So I know that this angle and this angle are alternate and the same. So let's say this one is 100 degrees. This one also would be 100 degrees. And this is a straight line. So these two must add to 180. So these two must also add to 180. And they are called co-interior angles. And they add to 180 degrees. They're not equal. They add to 180 degrees. And they make a kind of a F or a C shape, maybe, if you want to use a. So they form a C or a backward C. Now, like these, when two angles add to 180 degrees, they are called supplementary. When two angles or more add to 180 degrees. When angles add to 90 degrees, they're complementary. How I remember the difference between supplementary and complementary? S for straight line, 180 degrees, straight line. So we always know that two angles on a straight line add to 180 degrees. And they are supplementary angles. And one more of these we're going to do. So we'll draw our parallel lines again. We have a transversal coming across here. It's parallel. What happens if we got something here and here? So if we look at it, it's in the same position. If you think about it, in this little crossing point, it's the one in the top right, and then this crossing point is the one in the top right. And because these two lines are parallel, and this line is just a straight line, won't change direction, this angle must equal this angle because they correspond to the same point, same crossing point. They are called corresponding angle. And they are equal. Okay. So when these words, if you're ever asked for an angle relation, what's the relation between these two angles, you could say they're corresponding. If you're asked for a reason or a relation, oh, these two angles are the same because they're alternate angles. These two angles are add up to 180 because they are co-interior angles. Okay. All right. Any questions on any of that? No questions. Okay. If you have a question, you can stay online, but for the moment, I am just going to put some work up on ManageBack for you guys to work on based off this. We will. Can I rejoin? Can I rejoin? So I'm trying to rejoin so I can stop the recording. Hey, I'm back. Okay, so I'm going to stop the recording. All right. So